Right, hello Year 10. I'm going to go through the paper with you so that you can obviously listen to this at your leisure and go through the paper as well. This is going to be quite a long one. As you know, it was quite a long paper. So let's go through. Okay, so question 1A, nice and easy. When you're multiplying, you add the indices. So 6 plus 4 is 10, so it's g to the power of 10. When you're dividing, you subtract the indices. So you do 10 take away 3, and so you get k to the power of 7. 10 take away 3 is 7. Okay, moving on to C, gets a little bit harder. Remember, when they are next to each other like this, and obviously C is C to the power of 1, we multiply the indices. But so if I do that, so 1 times 2 is 2, so we know it's going to be C to the power of 2. 4 times 2 is 8, so we know it's going to be D to the power of 8. So we've dealt with this bit, but we've got to be careful. We have to also do 3 squared as well. So we've got to do that as normal. So 3 squared is 3 times 3, which is 9. So it's going to be 9c squared d to the power of 8. Luckily, if you did not manage to get the 9 and you got the c squared and the d to the power of 8, you still got 1 mark. So you should always still give these questions a go. Okay, solve the inequality the same way you would a normal equation. We're going to take away 7 from both sides to get rid of the plus 7. So we're left here with 4x is greater than 2 take away 7 is minus 5. Then to get rid of the times by 4, we're going to divide by 4, like so. And so we get x is greater than minus 5 over 4. You can leave it as a top-heavy fraction, or if you want, you can write, I should write this. So it's greater than minus 1.25. That is also fine as well to write both, especially as you have a calculator, so you can actually work that out for yourself. You do get 1 mark if you somehow had forgotten to replace the inequality sign and put an equal sign instead, okay? So it's still, again, worth working these out. Right, show that. So remember, even though you can do it on your calculator, you have to show that you understand how to do it by showing all your working. So I'm going to make both denominators 15 by multiplying the first one by 3, top and bottom by 3, and then the second one, top and bottom by 5. So the first fraction becomes 12 over 15. The second fraction becomes 10 over 15. Add those two together and I get 22. So 12 plus 10 is 22 over 15. And then I turn it back into a mixed fraction by saying how many 15s go into 22? 1 and 7 remainder. So 7 over 15. And that's my full 2 marks. For part B, I need to make both a top heavy fraction. So 2 1/4, so 2 times 4, add the 1, makes 9/4, divided by 2 times 3, add the 1, 7 over 2. Leave it, change the sign to multiplication and flip the second fraction, so it's 2 over 7 instead of 7 over 2. 9 times 2 is 18 over 4 times 7, which is 28. then we simplify. 2 is the biggest number that goes into both 18 and 28. And so that gives us 9 over 14, which is what the answer called for. And interestingly enough, you got 1 mark for simply doing this bit, for turning both fractions into top-heavy fractions. So it's always worth attempting these questions. Okay, so on the grid, draw the graph of y equals 7 minus 4x. You have to draw your own table, or you can go straight into the graph, but I always draw my own table. It says from -2 to 3, so I'm going to go -2, -1, 0, 1, 2, 3. Because they want me to go from -2 to 3 on the x. And to find y, I'm simply going to do 7 take away 4 times -2 for the first one. So I'm taking this -2 and I'm replacing it in the x value. So that gives me, and again, you can do this all on a calculator if you get stuck. So it becomes 7 minus 4 times -2 is positive 8. So 7 plus 8 is 15. So that gives me 15. I'll quickly do the rest. 7 take away 4 times -1. So that becomes 7 plus 4, which is 11. Then 7 take away 4 times 0, which is 7 take away 0, because 4 times 0 is 0, which equals 7. Next one is 7 take away 4 times 1. 4 times 1 is 4, so 7 take away 4 gives you 3. To be honest, most of you would have spotted a pattern that the numbers are going down by 4 each time. But say if you didn't realise that, that's fine. You can still just carry on working it out. 7 take away 4 times 2. So that's 7 take away 8, which is -1. And finally, 7 take away 4 times 3, which is 7 take away 12, which is -5. So now you've got your table and you can start to plot the points, okay? So remember, x goes first, then y. So this first coordinate is -2, 15. Next coordinate is -1, 11. Next coordinate 0, 7. Next coordinate 1, 3. Next coordinate is 2 minus 1. And next coordinate is 3 minus 5. So you plot those. So let's quickly do that. -2, -2, 15 is here. -1, 11. Oops, not quite. -1, 11 is here. 0, 7. 1, 3. 2 minus 1. And 3 minus 5. So down here. Just going to make this a bit smaller so I can draw my lines straight through. There you go. There's my line. And you can see it's a negative gradient. There. Why didn't go down to 5? Somehow took out the 5. So 3, 3 minus 5 is down here. Okay, perfect. There we go. There's our straight line. Okay, next question then. Nice and easy upper and lower bound question. So it's not even asking you to find the area of or circumference of this circle. It just wants the upper and lower bound of the radius. It's to one decimal place. So that means to the nearest 0.1. And remember I told you that whenever you're doing upper and lower bounds, if it's to the nearest one decimal place or 0.1, half of 0.1 is 0.05. So you add 0.05 for the upper bound. I'm just using UB as a short way of saying upper bound, and you subtract 0.05 for the lower bound. So in this case, the upper bound is 7.65 and the lower bound is 7.55. Okay, next one. So this is a Venn diagrams question. Well, sets questions, and it's saying list the members of the set A and B. So they're saying that A is the factors of 100, and I'd start from there if I was you, because multiples of 5 you could go on till infinity. So I would list all the multiples of 100 because there's only so many you can name. So we've got 1 and 100, 2 times 50, 4 times 25, 5 times 20, 6 does not go into it, 7 doesn't, 8 doesn't, 9 no, and 10 times 10. So they're the only ones. And then what I would do is pick out the ones that are also multiples of 5. So you can see here 5, 10 is, 20 is a multiple of 5, 25 is, 50 is, 100 is. And so that's your final answer is 5, 10, 20, 25, 50 and 100. Okay, I think you needed to get at least 4 of those in order to get at least 1 mark. But there you go. All right, work out the value of x. So this was a Pythagoras question. They give you the longest side already, so you have to subtract. It's 12.8 squared, take away 9.7 squared. That gives you 69.75. And remember, you always have to square root your answer. So square root 69.75, and that gives you 8.35 to 3 significant figures. Okay, so 3 significant figures. Remember, you want 1, 2, 3 numbers starting from the first non-zero number. So 8.35. Expand and simplify. You can use the grid or the arrows, whatever you prefer. So m minus 8 multiplied by m plus 5. Fill it in. M times m is m squared. M times minus 8 is minus 8m. 5 times m is 5m. And 5 times minus 8 is minus 40. Put together like terms. So put together the 5m and the minus 8m. And you have m squared minus 3m minus 40. Okay, and you got 1 mark for getting all these 4 terms in the grid. So all these 4 terms here, the m squared, the minus 8m, the 5m, and the minus 40. Even if you didn't simplify, that was at least 1 mark. Okay, factorise. Lots of different ways you could have done this. The way I've taught you guys is to put it in its prime factors. If you are not very confident with factorising. So 5y can be split into 5 times y, plus 20 can be split into 2 times 5, and y squared is y times y. Now it's been separated by the add, and we pick out what appears on both sides. So we've got a 5 on both sides, and we've got a y on both sides. So we're taking those outside the brackets, so 5y outside the brackets. What's left on this side of the plus sign? Nothing. Remember that we just put a 1 there then. Plus, what we're left here is 2 times y. 2 times 2 is 4 times y, so 4y. And that's it. See, anything to the power 0, it doesn't even matter what's inside that bracket. It could be 1,135,651. It doesn't matter what is inside that bracket. As soon as you raise it to the power 0, it is 1. Anything to the power 0 is 1. Okay, D. To solve this, so the first thing to do, which I think got you 1 mark, is to multiply out this bracket. So 3 times 2x is 6x. Take away 3 times minus 5 is minus 15. And then you've got 9 take away x over 2 on the other side. Then, to get rid of the divide by 2, I'm going to times by 2 on both sides. So remember, on this side, it's just getting rid of the divide by 2. And on this side, we're going to have to times by 2 to give us 12x minus 30 equals 9 take away x. Now it's super nice and simple. I'm going to add x to both sides to get rid of the take away x. Remember, you always do the opposite to what it's doing to get rid of it. So it is subtracting x here, so I'm going to add x. On this side, it's going to give me 13x, take away 30. And then on the other side, we've just got the 9 left. Then, to get rid of the take away 30, I'm going to add 30 to both sides to give me that 13x equals 39. And then finally, to get rid of the times by 13, I'm going to divide by 13. And again, you can do it on your calculator if you don't know your times tables off heart. 39 divided by 3 is, 39 divided by 13 is 3. So x equals 3. So x equals 3. And that's your final answer. Okay, next one. This one we did in class, but I think because it's a new thing that we've learned. Perhaps you didn't quite spend some time revising this. This was called the difference of 2 squares. So if you're going to revise this again, it's a difference of 2 squares. And so remember, we said we can do this where we've got a subtraction. So we need 2 things. We need a subtraction going on, and we need some square numbers, and 9 and 4 are both square numbers. And all you do is you square root the 9, so that's 3x, and square root the 4, so that's 2y, and you have two brackets. One's going to be an add and the other is going to be a subtraction. It doesn't matter which way round you write the two brackets. One has to be 3x plus 2y and the other is 3x take away 2y. Okay. The next one, you want to express 7 8 take away 8 plus 3 over 4x as a single fraction. That means I have to make both denominators the same. You could multiply the two denominators and make them both 32x, but it means that at the end you have got to do some cancelling down. You have to do some simplifying. The lowest common multiple that I can make both is I'm going to make them both 8x. To make this one 8x, the first one, I'm going to times by x, times by x. So now that becomes 7x over 8x. Take away. To make the second one 8x, I'm going to times by 2, and I have to do it to top and bottom. So, timesing this by 2, I get 2x plus 6 over 4x times 2, which is 8x. Now that they have the same denominator, I can put them together so that it becomes over 8x. You've got to be a little bit careful because your subtractors, you've got to be careful with signs. I've got 7x take away 2x, which is 5x. And then you have to be careful because you've got the take away here, the take away plus 6 becomes take away 6. So our answer is 5x take away 6 over 8x. 9. So it says that A, B and C are 3 sets. A and B is an empty set. So this symbol here means it's an empty set. It means that there are no items that belong in A and B. There is no overlap whatsoever between those two sets. So normally, if A and B wasn't an empty set, we would see this scenario here. But because it's an empty set, there's no connection, there's no overlap, B has to be separate. So B is going to be over here. And then I know a lot of you got scared with the sideways n here, which we have done, but again, probably not in as much detail, but it's good these things come up, is subset. So this symbol here means that it's a subset, that it belongs to. So it belongs to. So C belongs to A. An example would be, for example, if I said A was the set of types of shapes and C were different types of triangles, different types of triangles is a subset of shapes, so it would belong inside. Okay, so C would be inside because whatever belongs in C is also part of A. Okay, so this is how you would draw it. And then finally it says, on the Venn diagram, shade the region that represents A and not C. Again, we've done this notation. Remember, the dash means not C. So A and not C is all of this. So A but not C would be all of the outside, and we don't go inside C at all. So it'd be all of that area there. Okay, question 10. Again, we've done this before, just need you to practice it. To find the equation of the line, you need two things. You need the gradient and you need the y-intercept. And it's worth doing these questions. It's 3 marks. Even if you just find the gradient, that's at least 1 mark, and we can all do that. So the gradient of this line is your y values. So you take the second y value, minus 48, and take away the first y value, 12. So minus 48, take away 12, divided by your second x value, 19, take away your first x value, so minus 5. And that is, so minus 48 take away minus 12 is minus 60. And 19 take away minus 5 makes plus 5, which is 24. And minus 60 over 24 is minus 2.5. So our gradient of the line is minus 2.5. It means that our line is y equals minus 2.5x plus something. This is the something I want to find. I want to find what C is. I want to find out what the y-intercept is. The way I'm going to do that is I'm going to substitute in one of the coordinates. I think I'm going to go for minus 5, 12. But it doesn't matter which one you go for. You will end up with the same C as me. So wherever I see y, I'm going to replace with 12. In fact, I'll do it a different colour so that we don't get mixed up. So wherever I see y, I'm going to replace it with 12 because that's my y coordinate. So I'm going to write 12 equals minus 2.5 times x. Wherever I see x, I'm going to replace it with minus 5. So minus 2.5 times minus 5 plus c. So then I work it out, and I can use my calculator if I want. So minus 2.5 times minus 5 is positive 12.5 plus c. And then I take away 12.5 from both sides. Take away 12.5 from both sides to leave c on its own. So that c equals minus 0.5. I've got my final answer then. I know my gradient and I know my y-intercept. So I can put it all together now, and y equals minus 2.5x minus 0.5. It is also fine if you wrote your answer in fractions instead. So for example, if you wrote y equals minus 5 over 2x minus a half, that is also fine as well. So don't worry about whether you wrote it in fractions or decimals. Okay, this is the one that a lot of you hated, and admittedly it was quite an intense question. Right, so first of all, what we need to do is we need to know how much, in terms of either percentages or fractions, these two payments are. I personally think it's easier to turn them into percentages. To turn 3/8 into a percentage, you do 3 divided by 8. Remember, it's top divided by bottom, then times it by 100. That gives you 37.5%. So on payment 1, and payment 2, we have spent 37.5% plus 45%, which they've given us there. And so in total, 82.5% is what we've already paid. So 82.5% is what we've paid in payment 1 and payment 2. It means that if we subtract it from 100%, we're left with 17.5%, which is what payment 3 must be. So payment 3 must be the remaining 17.5%. So payment 3, which is $406, is 17.5%. This is now going to help us find 100%. First of all, we're going to find 1% by dividing by 17.5. Dividing by 17.5, both sides. That gives me that 23.2 is 1%. So 23.2 is 1%. Then we're going to times by 100 to give us that $2,320 is 100%. That means that is how much the whole holiday, was it a holiday? I can't remember. Yeah, it was a holiday. That's how much the whole holiday must have cost. 2,320. This is worth 5 marks. So up in this point, you have got at least 4 marks. Okay. So finally, we haven't finished. They want us to work out how much Anton had to pay for payment 2. So remember, payment 2 is 45% of the total cost. So we need to find 45%, which is 0.45 as a decimal, of 2,320. And we can just type that into our calculator. So 0.45 times 2,320, and that gives me $1,044. Okay. Please ask if you're not sure about that. It was quite a long question. Okay, question 12A. So on this one, we can deal with the indices first if you want. Remember, when they're next to each other like that, we have to multiply the indices. So we're doing 15 times 3/5. Unlike the show that questions of the fractions, you can do this in your calculator if you really don't feel confident multiplying fractions. But it's simply 15 times 3, which is 45, over 5, which is 9. Okay, so we know that it's got to be a to the power of 9. You got 1 mark for putting a to the power of 9. But don't forget, like last time, I've also got to do the 32 to the power of 3/5 as well. The way we're going to do that is we are going to split it as we did in class, 32 to the power of 1/5. and then the 3 outside the brackets. So remember, we split the 3/5 up, 1/5 here, 3 here. To the power of 1/5, we did this in class, is the same as finding the 5th root. Again, you just do that on your calculator, and you would have found that the 5th root of 32 is 2. So then we do 2 cubed, which is 8. So it's 8a to the power of 9. Okay. Right, B. Express 1 over 10x to the power minus 3 in the form px to the power of n. And I think sometimes you guys get scared when you see lots of letters. Again, it's just one of the index laws that we learned. We learned that when it's a negative indices, we find the reciprocal. Remember, we flip the number or the fraction, we flip it. So instead of it being 1 over 10x, it becomes 10x over 1. And the index becomes positive. That's all that happens. Now remember, in reality, 10x over 1 is just 10x to the power of 3. And 10x to the power of 3 is 10x times 10x times 10x, which is 1000x cubed. And that's it. And we've now written it in this form, okay, where we've got a number times x to the power of another number, so 1000x cubed. Right, part C. Again, there are a few ways to do this, but my favourite way of doing this would be, first of all, to combine the 4/5 and the 2y minus 1 over 2. In order to combine them, I have to make both fractions the same. So to make both fractions both denominators the same, in order to make both denominators the same, I'm going to multiply top and bottom on the first one by 2. So I'm making it over 10, and top and bottom on the second one by 5. So that gives me 4 times 2 is 8 over 5 times 2, which is 10. Take away, and I'm going to put brackets around it because we have to be careful with our signs here. 5 times 2y is 10y, and minus 1 times 5 is minus 5, over 2 times 5, which is 10. I can now combine it on the right hand side, but let's be careful with our signs. I've got 8, so I'm just going to highlight it, 8 take away minus 5. So be careful, 8 take away minus 5. 8 take away minus 5 is the same as adding 5, so you get 13. So we've got 13, and then we've got the take away 10y, and it's all over 10. Now you can do what we did in class, which is to cross multiply. So we're going to multiply that and multiply those two. So if I multiply 1 minus 2y by 10, I get 10y, no, not 10y, 10 minus 20y equals, and now I'm multiplying all of this by 3. 13 times 3 is 39. Take away 3 times minus 10y, which is 30y, minus 30y. And then I'm going to solve it as normal. I am going to add 30y to both sides. Which gets rid of the minus 30y. Leaving on this side 10 plus 10y equals 39. Then I'm going to subtract 10 from both sides to get rid of the 10 here. And that gives me 10y equals 29. Then to get rid of the times by 10, I'm going to divide by 10 to give me y equals 29 over 10, which you could write as 2.9. So 29 over 10 is 2.9. You can do that on the calculator. Okay, the next question in terms of recurring decimals was quite a nice one. Remember, our goal is to always make sure that the recurring bit is the only bit left on the right hand side of the decimal point. So I am going to say that x equals 0.17 recurring. Remember, the dot is only above the 7, so that's the bit that's recurring. The 1 is just singular. It's the 7 that's recurring. I'm going to times it by 10, and that gives me 1.7 recurring. The other one that would get me only the 7s being on the right hand side of the decimal point would be to times by 100. So I'm going to get 100x equals 17.77 recurring. And then I'm going to subtract the 2. 100x take away 10x gives me 90x. And then obviously the recurring bit disappears because 7 take away 7 is 0, 7 take away 7 is 0, 7 take away 7 is 0, and so on and so on. So these all cancel out. And you're left with 17 take away 1, which is 16. And then we're going to divide both sides by 90 to leave x on its own, so x equals 16 over 90, and then we can simplify both top and bottom are divisible by 2. 2 is the biggest number that goes into 16 and 90 to give us 8 over 45. And that's it. So we've done that. Okay, 14 is another big question. It's 5 marks, and you got, I think it was 1 mark for coming up with all the up and low. It might have even been 2 marks actually, coming up with all the up and low bounds. So even if you're not sure what to do, my first instinct would be to come up with a little table where I put the upper bound and lower bound for V, U and T. So we've got V, U and T. V is correct to 2 decimal places. That means that it's to the nearest 0.01. So to find the upper and lower bounds, I need to add or subtract 0.005. So my upper bound is 45.235. My lower bound is 45.225. The same goes for U. It's to the nearest 2 decimal places. So I'm going to add 0.005 for my upper bound. So it's 5.125. I'm going to subtract 0.005 for my lower bound, which is 5.115. Okay, with T I need to be a little bit careful. It says to two significant figures. Now, the last significant figure to two significant figures is to the nearest 0.1. Half of 0.1 is 0.05. So we're going to add or subtract 0.05 to find our upper and lower bounds. So the upper bound is 8.55 and our lower bound is 8.45. So I think that got you 1 or 2 marks. Now we have to actually put it into this formula here. So to find the upper bound of A, I'm going to take my biggest possible V. So I'm going to highlight all the ones I'm using for that one. I need to take my biggest possible V, which is 45.235. And I want it to be I want my final answer to be the maximum, the biggest possible I could get. So I'm going to subtract my smallest U. So I'm going to subtract my smallest U, which is 5.115. And again, I need to divide by the smallest t, because I want it to eventually be the biggest number. So I need to divide by a small number. So 8.45. That gives me, and I'm going to write a lot of the numbers I got on my calculator, which was 4.747928 ... Now, let's do the lower bound of A. Now, remember, I want the lowest possible number. So I'm going to take my lowest V, which is 45.225. And I'm going to take away the biggest U, again, because I want to make it a small number. So I need to take away the biggest number. So I'm going to take away my biggest U. I'm going to take away 5.125 and divide again by my biggest T. And this is all to make the number the biggest, the minimum it could possibly be. So that's 8.55. That gives me 4.690058, blah, 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 and so on. Now, this is the tricky bit. Well, no, not tricky bit, but now we can finally answer the question. It says, by considering bounds, and we've done that, we've got pretty much all 4 marks. We want the 5th and final mark. By considering bounds, work out the value of A to a suitable degree of accuracy. Our answer is going to be A equals 4.7. It says, give a reason for your answer. And my answer is that both upper bound and lower bound round to 4.7. Okay, so you look for what they can both be equal to, so what they can both round to be the same. And when you look at these, when you look at your upper bound and lower bound, where they are both equal is when we round to 1 decimal place. So that's 4.7. I can give you more questions like that in class if you want to practice that. Okay, some more index laws. Okay, so just like the one before, whenever the indices are next to each other like that, we multiply. So we're doing 8 times 3/4. Again, you can do it on your calculator if you're not confident with multiplying fractions, but it's just 8 times 3, which is 24, over 4, which gives me 6. So I know it's going to be y to the power of 6, and you've got 1 mark for getting y to the power of 6. But then remember, we've got to deal with the 16. So I've got to do 16 to the power of 3/4. And it's like we learnt in class. We've got to split the 3/4 up into 16, to the power of 1/4, and the 3 outside. So I've just split up the 3/4 into 3 and 1/4 there. Now remember that to power of 1/4 is the same as finding the 4th root. And you can do that on your calculator. The 4th root of 16 is 2, and 2 cubed is 8. So our final answer is 8y to the power of 6. Okay, part B. Given that 2 to the power of p times 8 to the power of q equals n, express n in terms of p and q. Unfortunately, this was another index law question, and what you had to do is, because this is 2 to the power of n, you wanted this also to be 2 to the power of something. So 2 to the power of p is already 2 to the power of something, times, now what could you rewrite 8 as 2 to the power of something? Well, 8 is the same as 2 to the power of 3. So we've got 2 to the power of 3, and you've got your q there. So 2 to the power of 3q equals 2 to the power of n. Now, what do we know when we've got the same base? We know that to get whatever n is, so n equals, we just have to add the indices because we're multiplying. So we're just going to add p plus 3q. So n equals p plus 3q. And that's it. That's your answer. But remember, these questions here that I've just been doing, including I think the next question that I'm going to do, which is another index law question. These are all grade 8 or 9 questions. So let's do the next one, which is another index law question. And this was quite tricky, and I would say this is a grade 9 question when it comes to, in terms of index laws. So let's have a look. We've got 18 times, so the trick again, if you look on this side, it's 3 to the power of something. So I know that I want to reduce everything here, which is going to be a little bit tricky, to 3 to the power of something. So I've got 18 times the square root of 27. Now, we learned that the square root of 27 is the same as 27 to the power of a half. And we've got the 4n plus 6 outside. So I'll just write that for now. Over 6 times. Now I'm going to split this up already. I know that 9 is just 3 squared. And then I've got the 2n plus 8 there. So all I've done is rewritten 9 as 3 squared, which is 3 times 3. The other thing I can do, again, because all I want is to have it all written in terms of 3 to the power of something. I know that 18 divided by 6 is 3. So 18 divided by 6 is 3. So it gets rid of the 6 on the denominator, and I've just got 3 at the top. Okay, so 3 is just 3 to the power of 1 times. Now, the 27 is the same as, so 27 is the same as 3 to the power of 3. So 3 to the power of 3 times 3 times 3 is 27. So it's 3 to the power of 3. And I've got it times by a half, so 3 over 2. And I've got the 4n plus 6 out there. And then at the bottom, I've got 3 to the power of 2 times n plus 8. Okay, we're almost getting there. And remember, this is all 3 to the power of x. 3 to the power of x here. So we're almost getting there. What I would do now is, remember, when indices are next to each other, we can just multiply them. So we've got 3 to the power of 1 times by, so I'll just get rid of that so you can see it clearly. So we're just going to multiply these two. So you've got 3 to the power of 1 times 3 to the power of, so 3 to the power of 2, so 3 over 2 times 4n. Again, 3 over 2 times 4, you can do on your calculator if you want, but it's just 6n, so 6n. And 3 over 2 times 6, so 3 over 2 times 6 is just 9. So it's just 9 there. Then over, multiply out the brackets, so we get 3 to the power of 2 times 2n, which is 4n, and 2 times 8, which is 16, 4n plus 16. So all I've done is multiply out the brackets. And then, again, same base, so I can add the indices because we're multiplying. And so we've got 3 to the power of 6n plus 9 plus 1, which is 6n plus 10, over 3 to the power of 4n plus 16. And then finally, because we are dividing and we have the same base, so you can see there that these two are the same base, we can subtract the indices. And so we have 6n plus 10 take away 4n plus 16. 6n take away 4n is 2n. And 10 take away 16 is minus 6. So x equals 2n take away 6. Okay, last question then. You know I like the grids, so I'm going to draw my grid. I'm going to do 2x plus 3 multiplied by x take away 5. Fill it in. 2x times x is 2x squared. 3 times x is 3x. 2x times minus 5 is minus 10x. And 3 times minus 5 is minus 15. So, then gather like terms. So you've got 2x squared, and minus 10x plus 3x is minus 7x. And then you've got the minus 15. Then draw yourself a bigger grid. And we're going to take what we just had, the 2x squared, the minus 7x, and the minus 15, and we're going to multiply it by the last bracket, so x plus 4. Let's fill that in. 2x squared times x is 2x cubed. Minus 7x times x is minus 7x squared. Minus 15 times x is minus 15x. 2x squared times 4 is 8x squared. Minus 7x times 4 is minus 28x. And minus 15 times 4 is minus 60. Gather your like terms. So you've got x squareds there, and you've got x is there. So on its own, you've got the 2x cubed. Then here you've got 8x squared, take away 7x squared. That gives you positive x squared. And then you've got minus 28x, take away 15x, which gives you minus 43x. And then you've got the minus 60. And that's the end of the paper. Well done.